Imagine a future where we finally discover the greatest mystery of the universe. Are we alone? In a universe filled with countless stars and galaxies, the possibility of another civilization is both exciting and terrifying. Today we take you on a journey of revolutionary discovery that could change everything we know about life in the universe. 7 trillion miles from Earth. An unprecedented discovery by the James Webb Space Telescope has sparked a wave of curiosity and excitement. What if we weren't alone? I think there might be a civilization in the Milky Way right now. Oh my God. Unbelievable. We will learn a lot over the next decade. 7 trillion miles from Earth lies an unprecedented discovery by the James Webb Space Telescope. City lights in space. This remarkable discovery has caused a strong wave of curiosity about the possibility of extraterrestrial life. The telescope focused on Proxima Centauri b, the closest exoplanet to Earth, and revealed unusual lights emanating from it. What could be causing these city lights on Proxima Centauri b? Could this mean the presence of life beyond our own planet? Let's explore how the James Webb Space Telescope detected these peculiar objects in space. The discovery of city lights on Proxima Centauri b by the James Webb Space Telescope could be the first solid evidence of extraterrestrial civilizations. For many years, scientists and people in general have been conducting research to better understand life beyond our solar system. Any evidence that is believed to support this space fantasy has been greeted with joy over time. Recently, the scientific community suffered a shock of life when strong evidence of life forms existing in space was observed by the James Webb Space Telescope. While exploring space and transmitting important information to Earth, the James Webb Space Telescope noticed strange city lights shining from the exoplanet Proxima Centauri b. As the name suggests, the city lights seem to illuminate a distant city. The possibility of an alien city on our star has stunned scientists. Each of them is baffled because it seems like this is the existence they have all been waiting for. If it turns out to be true, as everyone thinks, it means that there are intelligent life forms organizing civilizations far from what humans know in space, and we are only just discovering it. The possibility of confirmation of an alien city on Proxima Centauri b could redefine our understanding of the universe and our place in it. Looking at the lights of cities 7 trillion miles from Earth, NASA engineers can't help but wonder how long these lights have been shining in space, waiting for humans to develop the technology needed to detect them. David Kipping, an astronomer at Columbia University, described the exoplanet Proxima b, where the city lights were spotted, as a challenge. He said this is because the star system closest to us exhibits different heating patterns that are unlike those on other planets. Regular rocky planets are known to absorb sunlight and emit infrared radiation. However, this is not the case with this exoplanet, as its infrared nature is quite different from that of its host star, Proxima Centauri. This allows the James Webb Space Telescope, JWST, to make good observations, and the telescope has proven to be an ideal tool for the job. JWST can easily detect infrared wavelengths, the signature heat signature of Proxima b, which will play a key role in uncovering the broader secrets of its atmosphere. Could JWST's advanced infrared capabilities reveal more secrets about Proxima Centauri bandamp, #039's atmosphere and potential for life? This would be the result of JWST's latest infrared imaging technology. Scientists plan to use the telescope to explore the mysteries surrounding the planet's atmosphere and conditions. They also aim to use the Webb telescope to test the habitability of the exoplanet. The James Webb Telescope has the infrared sensitivity needed to explore what happens at night at Proxima Centauri bandamp, #039. Capturing the faintest rays of light in the cosmic darkness is usually a challenge for space telescopes, but not for JWST, which can capture even the tiniest rays of light from space. It is the perfect tool to test whether rumors of city lights on the dark side of Proxima are true or false. Any artificial light in the universe can be detected by a telescope as long as it is in a frequency band 1,000 times narrower than starlight. JWST's ability to detect faint artificial light in space could provide the first concrete evidence of extraterrestrial civilizations. How does Proxima Centauri b compare to planet Earth? Proxima b demonstrates an interesting relationship between stellar properties and surface interactions. The exoplanet's day side contains numerous solar panels that harness the bubbling radiation energy that the star possesses. The spectral edge also reflects light rays from the ink at the same time. As Proxima b completes its orbit around its host star, Proxima Centauri, it experiences day and night phases much like we do on Earth, with warm, solar-rich days and cool evenings. The planet is known to have temperature fluctuations determined by its composition. For example, if there were no atmosphere on Proxima b, the difference between its day and night cycles would be large and evenly spaced. Without the moderating influence of an atmosphere and ocean, the day side would be as hot as a black body, while the night side would be plunged into a terrifyingly cold darkness. The magnitude of the temperature variation is a good topic for astronomers to better understand Proxima's atmospheric composition. Could the unique temperature variations and atmospheric composition of the Proxima Centauri strip hold the key to understanding its habitability? With its unparalleled infrared imaging capabilities, JWST can effectively examine the planet's thermal emissions to provide relevant data on its atmospheric properties. Interestingly, the JWST's orbit around Earth matches the orbital period of the Proxima band, allowing for a full observation of its day and night cycle over 11 Earth days. Since Proxima band does have an atmosphere, the next step will be to assess the chemistry of its atmosphere to determine whether it could support life. The presence of gases such as oxygen, water vapor, and methane is a good indicator of whether life exists on the planet. If these elements can be found on the planet, it means it supports habitable conditions. A successful determination requires scientists to be meticulous enough to capture and examine light rays passing through the planet's atmosphere. This is an extremely difficult task to perform, even though JWST has excellent capabilities in characterizing planetary atmospheres. The discovery of key gases in Proxima Centauri bandamp, #039's atmosphere could be the first step toward confirming its habitability. JWST has another main goal. The telescope is designed to analyze changes in water vapor, carbon dioxide, and methane concentrations only. When it comes to determining the amount of bound oxygen, a key indicator of life, JWST is limited in this area. Still, telescopes have good reasons to look for other features on the planet. One of those reasons is ozone, which gives the atmosphere its precise energy levels. It's also worth noting that the James Webb Space Telescope isn't all-powerful and can only observe some of the habitable worlds closest to Earth. When it comes to in-depth atmospheric studies, astronomers are now turning to ground-based observatories like the Extremely Large Telescope, ELT, affectionately known as the YELT. The YELT is scheduled to start operating in 2028 and is carefully positioned to look deeper into the atmospheric structures of distant exoplanets. What secrets will the YELT reveal when it begins operations in 2028? Could it reveal evidence of life on distant exoplanets? It will generate data about these planets to provide a complete and accurate overview of their habitability. NASA scientists and the public are eagerly awaiting the deployment of space telescopes like this in the future. But until then, the James Webb Space Telescope will continue to be an essential tool in the effort to uncover the mysteries of distant exoplanets. Despite its current limitations, the James Webb Space Telescope has the potential to yield insights that will revolutionize our understanding of exoplanet discovery today and in the future. The deployment of future space telescopes promises even more exciting discoveries that could revolutionize our understanding of the universe. Scientists have a goal for future space telescopes: to reduce the amount of bright light coming from a planet and its host star so that astronomers can clearly see the light reflecting off the planet itself. They plan to achieve this by using either an internal mask or a giant umbrella-shaped external satellite, like blocking the sun's rays with your hand so you can see the object more clearly. In an effort to reduce the intense brightness coming from its host star, future telescopes will be better positioned to study the faint reflections of light from a distant exoplanet, allowing for a clear analysis of its atmosphere and its potential to harbor life. But this is not without its problems. Scientists will need to distinguish between gases produced by biological processes and those produced by geological processes such as volcanic activity. Astronomers are continuing to work to understand the characteristics of exoplanets so that they can detect signs of life and distinguish them from false positives. The Webb telescope presents an overview of the scientific advances coming from exoplanet research, offering a glimpse into the amazing discoveries we have yet to make.